Good afternoon, everyone, and good evening if you're in the Netherlands, where I'm from. Hello. Thank you all for being here. I'm excited to get this talk going. I realize it might be a bit of a niche subject, so we'll start off a little bit different with some trivia questions to see how much you know about Google Workspace, or if you even know what Google Workspace is. So the first thing is, did you know that Google Workspace is not the same as Google Cloud? It's two different things. Google Workspace is basically the SaaS offering of Google Cloud. It's a suite of productivity tools. It's basically like Microsoft 365, and Google Cloud is more like Azure. So that's how you should look at it. From a security perspective, there's actually some really interesting things going on within Google Workspace. Out of the box, there's almost, last time I counted, 50 security rules that you can that are actually used to trigger alerts and notifications about weird stuff going on. But did you also know that most of these security alerts do not generate an alert, even though they're really good? So what you can do is actually you can reroute all your email in your domain to a whole different domain, and it won't trigger an alert. Or you could simply make a user a super admin and it won't trigger an alert. The alerts are there, but you have to enable notification, etc. From an incident response and analyst perspective, there's something very nice about Google Workspace that you probably heard yesterday in the keynote. You cannot disable audit logging in Google Workspace. It's there for you. So if you do IR as a consultant, you can just get into an environment and be like, can I have the audit logging? And it won't be the story about Microsoft where they're like, it wasn't enabled at the time, so you kind of stuck with that. So that's great. That was Google Workspace introduction. A little bit about myself. So my name is Korstiaan Stam. I'm from the Netherlands, as you may already heard or not. I started my career at Nordwave, which is a cybersecurity firm, and then moved to PwC, did a lot of incident response there. I was lucky enough to lead an IR team there, which was great. But at some point I thought maybe I can do things a little bit different or maybe even better. So then I started my own company, and it's called Invictus. You might have seen it because it's on every slide, it's on my shirt, it's everywhere. So that's my company. I also really enjoy teaching, and that's why I started teaching at the University of Applied Sciences in Amsterdam. It's like a part-time job. And then I got an opportunity to work with Sense on the Cloud Incident Response course. So if you're doing 509 this week, you might be seeing a lot more of me. So good luck. And yeah, this was enough about me. Let's talk about the actual research, why I'm here and why we're discussing this topic. So I mentioned I started at, I did a lot of incident response at PwC, and I think because we were an accounting firm, we saw a lot of financial related incidents, and that's mostly business email compromises. So people getting into an email environment, doing all kinds of shady stuff, and then trying to get money out of it. So I don't know, changing invoices, doing internal phishing, etc. But the ultimate goal was getting monetary value out of your attack, so to say. Which was really cool for us and the whole team at PwC. And we created a lot of open source projects which are actually still around and super popular. So if you've ever do something with Microsoft 365, please check out the Microsoft 365 extractor. It's basically gets all the logs. And if you have Splunk, if you can afford it, I also created an app, and it will automatically analyze all the data. And together with the team, we created the BEC guide, which is actually something I'm really proud of everyone that worked in it, by the way, not just me, because it's really good, and it helped a lot of other incident responders around the world responding to business email compromises. Well, this is all fine, but it has nothing to do with Google Workspace. The thing is, Google Workspace is like the unknown thingy. There was not a lot of data available on Google Workspace, who was using it. There was no research on forensics, nothing. So I was like, maybe I should write a little tool or something to get to acquire, for instance, all the audit logging, which is a nice start for your investigation, of course. That was our original idea. And I also work with the University of Amsterdam, and they're like, do you have some research ideas? And yeah, I did. I was like, maybe we can do something with Google Workspace. So, but these students need to prove that they're really smart, of course, and need to prove a lot of points. So they were like, can we take it one step further? And this is sort of like the holy grail of, I guess, doing incident response is, can we maybe automate analysis as well? So we acquire data and we also analyze it automatically, which is very dangerous, I know, but we try to do it. The reason is like analyst time and incident responders time is very valuable. And when you do incident response, you need to get a lot of answers very quick if you're in a case and there's a lot of pressure. So what can we do to basically bring the analyst time down? That was the original idea. So I worked together with two very smart guys, and I want to give a proper shout out to them. Betjan on the left and Greg on the right. They would love to get some followers or connection requests after this talk, so feel free to stalk them. They're really nice guys, and they helped a lot with this research. And honestly, without them, I probably wouldn't be here with this talk. So that's the background. So basically, what can we do on the Google Workspace end in terms of acquisition and also automatic analysis? Google Workspace, I won't try to repeat too much what the keynote was yesterday, so I only have a few slides on Google Workspace, what it is, and I guess the forensic side of it. So as I mentioned, it's the commercial suite of products from Google. So you basically have Gmail, Meet, Calendar, Drive, but it's all like officially supported. You have more storage space, etc., etc. And if you have the right licenses, you can get a lot of security features as well. So that's what Google Workspace is. There's no real recent data, but from what I've seen, which is anecdotal evidence, it's getting pretty popular. Of course, Microsoft 365 is by far the market leader, but after that, I suspect Google Workspace is the #2, but I don't have that data because they don't publish it. In Google Workspace, it's a SaaS offering, and as we've learned yesterday in the keynote as well, if you have a SaaS solution that's in the cloud, you basically rely on the cloud provider to give you data. And Google does that. They have audit logging available. And the audit logging is separated into several what I call log types. So there's 5 main categories. So it's admin, group, login, OAuth, and SAML. That's like the main categories of logs. And then there's server-specific events. So let's say you use the calendar to make an appointment and someone accepts that meeting, that will be logged. If you have Google Drive and you change the sharing settings or you send out an external invite, everything gets logged. It shouldn't come as a surprise, but Google is really good at logging and they know so much. So if you ever look at these logs, you'll be surprised at the level of detail that's available in these logs. The good news is the retention is 6 months at least. So what you can do, which is a nice trick if you also use Google Cloud, you can forward the logs from Google Workspace to Google Cloud, and then you can configure the retention period to go much longer, which is pretty nice. But 6 months is already really good. I mean, if you haven't, I think most of the incidents I did were, I think after 6 months, they sort of realized there was an incident. So yeah, 6 months is pretty okay. So this is the thing I mentioned in Google Workspace, the admin center. You can simply say, oh, please send all my logs also to Google Cloud, which is, if you have both Google Workspace and Google Cloud, I think it's a pretty good one. I don't think it's very expensive either. So you should probably do that. If you want to take a look at the logs, you can use that Workspace Admin Center. There's a little section in the reporting that says auditing and investigation. And you have like a visual interface where you can search for a filter for admin events, group events, everything that I just listed, all the record types, you can simply filter on those. You can do some more advanced filtering with Boolean filtering, and you can filter on IP, you can do all kinds of crazy stuff there, which is pretty okay for basic, quick investigation. And then you can export to Google Sheets and CSV nowadays, so that's pretty nice. But not what we want. This is an example of the audit logging when we export it out. What we really want to do is build a tool, give it to the world, and where everyone can just use the tool to grab all the data from their client or from their own environment and do the magic with it. So that's why we do not just rely on the graphical interface of Google, and we go a step further. And now we come into the topic of Alpha. What is Alpha? Alpha stands for Automated Audit Log Forensic Analysis for Google Workspace. Well, Alpha has 4 letters, and I think there's a lot more words there, but we thought Alpha sounds a bit better, so we stuck with Alpha. What it is, it's an open source tool, and it's available right now. I think I disabled or I cloned and made it publicly available this morning, so it should be available for everyone to use. What it does, it can acquire all Google Workspace audit logs. And the next step is, of course, the analysis step. This is where the magic comes in. It leverages the MITRE ATT&CK cloud framework to basically classify events. So what it does, it grabs all the logs and then it tries to figure out, based on a mapping, is this event related to, I don't know, initial access, to persistence, or to another phase of the MITRE framework, and then it basically classifies that event. And the next step is, using that classification, you can actually sort of automatically identify interesting activity, because you can, as a tool or as an analyst, you can say like, oh, there's a lot of interesting, or there's a lot of mapped events, because not every event can be mapped to the MITRE framework, of course, but there's a lot of mapped events with a MITRE technique or sub-technique in a certain period of time. So that might be interesting. So that's a start. We went a step further and we tried to build something that identifies kill chains. I don't think I think for the purists among us, kill chains is maybe the wrong word, but what it basically does, it tries to identify attack chains. So where we, based on the logging, can we identify an attack? Can we identify multiple phases of an attack based on the logging? And what it can also do is, after it has identified these interesting activities or the kill chains, it can export it out. So you end up with like all the logging on one side, so all the exported logging, but you can also use a separate file, which is way smaller, with only the things that we think as authors of alpha to be interesting for you, which is very dangerous, but I'm going to be transparent about what it does, so you can make your own decisions on how to use this. And it uses super complex algorithms to perform this magic. It's machine learning AI. No, just kidding. It's not very complex. I will explain everything in this talk. But it's good to know how it works in the backend, basically, to do this automated analysis. So the first step is acquisition. So how can we acquire this data automatically, and how can we get everything? This is how you set it all up. There's a specific API, the reports API, that basically exposes this information. And there's two types of reports in the API. There's activity reports and usage reports. And as the name sort of suggests, activity report is based on what kind of activity did we record in a certain category. So in admin events, or in Google Drive events, or in chat events. Whereas a usage report is more like, what did a certain user do? So made a decision to use the activity API, because within the activity report, or I should say, we use the activity logs from the reports API, because you can still filter on a user there. So it's a no-brainer to go for this one. If you want to use this in your client environment or in your own environment, you need two things. You need something with Google Workspace. You need basically a user that has a custom role called reports administrator, or that basically you have to attach a certain permission which falls on the reports administrator, and you can tie that to an account. Or if you are going the easy route, you can just request a super administrator account. It's a bit more secure, I would say, for an acquisition at your client to just request, oh, I only need this. So set up a custom role for that. Because we do something with a so-called OAuth application to get the logs and to authorize, you also need something in the Google Cloud. What you need to do is you need to create a Google Cloud project. And within that project, you need to enable a certain API, so the admin SDK API basically, and you need to register an OAuth application. The OAuth application, what it does, it is basically, you can give it a certain you can give it a scope, saying basically, oh, this application can look at this API, and OAuth will try to perform authentication and authorization on your behalf. And then you as a user, as someone with the role reports administrator, needs to approve that action. I made it visually, so it's a bit more clear. Maybe yeah, it's a bit more clear in the next slide. But this is also how most of the clouds nowadays work. If you want to grab logs from APIs, you need to use an OAuth application. So yeah, so we can interact with the API to get the data, and we'll use an OAuth application. It's basically 4 steps. So you can create a new GCP project. This is optional, but I suggest if you do acquisition often or frequently, that you always have a separate project at the client side, because it's easy to track costs and permissions, and you can easily also shut it down afterwards. Within the project, enable the API, and then register an OAuth application. This is really straightforward. It's just click, 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 give it a name. And in the end, you will end up with a credentials file. And this is really important because the credentials file will be used in alpha to perform the right calls and to ask for the right permissions. Because this is very common, like this building an OAuth application is being used by Microsoft, Google, probably also in AWS. The instructions are very clear and very well documented. What I've done is I've made a description on GitHub. If you click on this link, you'll find it. And there's also a whole YouTube video where I just go through each of the steps, and I do it really slowly. And you should be able to just follow that, and then you're good to go. So even though this may sound a bit daunting, it's actually pretty straightforward. Most important thing you need to remember is at the end of this phase, you will have a JSON file that you'll need to use with alpha. So using alpha, it has 3 modes. Alpha acquire, well, it acquires all the logs. Alpha analyze, it acquires and analyzes the logs, so it tries to identify interesting activity. And alpha load, and you can use this if you already have previously acquired the logs and you just want to use the analysis functionality of the tool. To use the tool, simply download it from GitHub, and then you can use pip to install it. So go to the folder, run this command, and it will install it. Then you need to initialize it, and this may be a bit different to other open source projects, but we thought it was a good idea to use initialization for each project, because let's say you are a consultant or you're doing more projects, you may want to tune alpha to a certain environment. So you might want to change some variables, and with initialization, what it does is it automatically creates a project folder, and within the project folder there will be a config file that will be unique to this specific project. So you can do all your tuning there without actually changing the main product. So you need to run alpha in it, and then a project name. You can decide what the project name is. It automatically creates a folder structure for the logs and for the configuration. In the configuration directory, you throw in your credentials file that you have from the previous steps, and you're good to go. So what can you do in terms of acquisition? You can just be like, oh, give me everything, alpha acquire. You can say, oh, I only want to have the admin related activities, or I only want to have the user login activities, or only the drive activities. And then you have to use -- log type equals the thing you want. And as I mentioned, you can also simply filter on users. So let's say you get called into an incident, or you suspect something is going on with a certain user. You can simply also just collect that user's audit logs. Last but not least, you can also acquire based on the time frame. So let's say most of the instances you have an ID on when it happened. So then you can simply select a time frame. I think I made a video about this. Yeah, I did. As you can see, I don't know. Yeah, it's pretty good. I'm now inside a project that I created. So I initialized a project called Sense Project, and automatically I already added the credentials file. So now I can just run it. What will happen is if I run it, it will do the authorization with OAuth. So it will open up a browser and it will say, please log in with an account that has the right permissions. It's pretty quick, but basically this was successful. And now it shows you all the logs it acquired per log type, because I said grab everything. And in the end, you can still see it on this screenshot. You will have a little bit over, you have 9.5K activities saved to a data folder. And this video was not fast forward or something. So within, I think, 20, 30 seconds, we actually managed to get almost 10K events. So it's really quick. So yeah, I should probably use this over an API export, like a GUI export or something, just because it's really fast. So what happens next is, as I mentioned, the initialization of the project results in a data folder, and a data folder contains the acquired logs. And what Alpha does, it automatically creates a folder with the UTC date and time of the acquisition. So to automatically, you can always go back and be like, when was this acquisition? You can just look at the folder name, and you will also never end up with duplicate entries or something. So here you'll see, I think it's around 20 different log types that have been acquired. Here you'll also see a few that actually are really small, and it actually means that they are empty. So they're 18 kilobytes. In the new version that's actually released now, it won't acquire empty logs. So it will only grab logs when there's data there. So it's pretty nice. So now, yeah, you basically have a decision to make. You can either say, well, this is nice. I can use this tool to acquire all the data, and then I can run off to my own SIEM or my own data analysis platform or whatever you would like to use and stop. But I would love for everyone to come along with the journey of analysis. And this is the second mode of Alpha. This is the analyze mode. The way it works is, and this is basically where I'm explaining the magic. It's not that magical, but it's pretty cool. We use the MITRE ATT&CK cloud framework. It's a collection, for the people that don't know, it's a collection of techniques that have been observed by threat actors to be abused, basically. So let's say under the privilege escalation phase, there's a technique called valid accounts. And basically what happened is that certain threat actors use this tactic or this technique against a technology, in this case it's Google Workspace, to abuse it. So what we do is we take the original event that's on the left-hand side, and I've made a little red box around it. So the original event is around the creation of a user, and I've blurred out some details. It's probably my own home IP. So this is the create user event. So this is the type of event. What we do on the right-hand side is we've made a mapping, and the mapping is made towards the MITRE technique or sub-technique. So what you see is on the right-hand side, you'll see that this specific event belongs to the persistence phase, and then to the create account technique, and then to the sub-technique cloud account. So that's basically the structure of the event. And the link is there for this specific one. If you look a little bit further down, there's download report. This is a Google event. And this belongs to what we think the collection phase of MITRE, and then to the technique data from information repositories. So this is how we have defined what original Google Workspace audit logs basically are in terms of activity. So it's really important to remember this file is part of course, the tool. You can modify it, you can update it, but this is what we have decided to be the case. And you can make suggestions if you don't agree, by the way. In the next step, what we do is we take that original event that's mapped, we give it a score based on the associated MITRE phase. So here you will have the different phases from MITRE. So this previous event was related to persistency. So that event will get the score of 1 because it occurs in the first phase according to us. And the next thing it will do is it will create basically a running score where it compares the score of this event. So let's take this example of a persistency. So we have a score of 1, and then we'll compare it with the next event. And if the next event has a higher score based on the MITRE ATT&CK phase that it occurs in, we'll up the running score with 1. If it doesn't follow the MITRE ATT&CK flow, basically, so from persistence towards collection, we'll subtract 1. So the running score will be -1. This allows us to generate what we call a kill chain statistic. And this is basically where we have a number of events, so at least 5, that have occurred, where we do this comparison. So we check event 1 or event 2 is in a later phase in the MITRE framework, so the running score is updated. event 3 is also updated. So let's say we have 5 events that follow the MITRE ATT&CK chain. The running score will be 5, because every time the next event follows the MITRE ATT&CK flow. Okay, and then we divide that number by the number of events. So we have 5 events that follow the chain, and we have 5 total events. Well, what happens if we divide 5 by 5? We'll end up with 1. So the kill chain statistic is 1. What does 1 mean? It's the perfect kill chain. It will never happen, only if you have a fabricated data set, of course. But that means that each event basically follows the MITRE ATT&CK framework, which never happens. You can also have -1, which is a reverse kill chain, where an event basically goes backwards. So you have 5 events or 10 events that each time go back in the MITRE ATT&CK framework flow. So you will have an event in lateral movement, followed by an event in credential access, for instance, and then followed by one in privilege escalation. Highly unlikely. If you have a score that's close to 0, that represents basically random events. So yeah, that's maybe more common, because you will have in a normal data set, you expect there to be normal user activity, maybe bad or suspicious activity, followed by normal activity. So this is what the tool tries to do. It tries to identify blobs of data, so to say, that contain interesting activity. Step 7, for each chain of events, so it will generate the kill chain statistic, and if it's higher than 0.6, it will be available for export. So then what we can do is with one command, and I'll show you, it automatically exports all these subchains to a separate file. So in that separate file, you should only have events in an ideal world that are interesting. And this is a very important point that I want to make. We are not in the business of saying something is malicious. We are basically pointing out, based on audit logging and our knowledge of incidents and what we think is important, we come up with a bunch of interesting events. But it's up to you, to the analyst, to the incident responder, to actually determine, is this malicious? Because if we follow the steps of MITRE, it can also be that a normal administrator creates a user, adds that user to a certain group, does some more legit activity, which actually follows all the MITRE steps. So what we do is we'll give you interesting events, but they're not necessarily malicious events. So that's where you all come in to define that. That's why they pay us. The analyze function and the commands you can use. So what you do, if you run alpha analyze, it will drop you in a shell, and you can do all these things that I just showed you. What you can do is you can run a.kcs, which stands for kill chain statistic, and you can run it on the whole data set or a subset of the data, and it will calculate the kill chain statistic. So it will give you the number, whatever that is. You can run the a.subchains command, which will automatically show you all the identified chains with a value higher than 0.6. And what you can do within the tool as well is basically get a summary of the events within a certain slice of the data. So let's say we have a subchain that consists of event 1 to 8. We can use the summary command with 1 semicolon 8, and we get a summary of the events, which is nice, but I'll show you what it looks like. Last but not least, you can export out these activities for further analysis. So what does it look like? So you have to separate anything that's belong to 7 and 8. So in 7, what we do is we call a.subchains, and it tells us that it found 3 subchains in this data set. And one subchain, for instance, has a score of 0.9, which is very high. There's not a subchain that starts at event 75 until 85 as a subchain of score of 0.65. So it might also be interesting. With the summary command, we can see what type of data is in there. And this will give you basic information like what the type of event it is. So in this example, it says change user access, changes ACL. And in the end, it's basically saying, oh, let's configure email forwarding, which is very interesting. So using this method, we hope to give you some pointers as to what is interesting in a data set of Google Workspace audit logs. You can also use load, but it's, as I mentioned, it's the same, but you can just use previously acquired data. What I really want to show you is actually, is this any useful? Or is this useful at all? Because we've created this and we've tested this, but the talk was about detecting malicious actors. So what do malicious actors do? Well, they attack your Google Workspace environment. How do they do it? In a few ways that I've chosen, I've simulated for this test. I did 3 attacks: a business email compromise attack. So getting your email environment through phishing or through leaked passwords, set up forwarding rules, perform data exfiltration, change invoices, for instance. Attack 2 is a malicious application. This is more like a SolarWinds type incident where you set up an application and you give it a lot of permissions, and then you send what you can do in OAuth. You can generate a URL that authorizes that application to perform these activities. So let's say you create an application with a lot of permissions. You can then send a link to a user, and when the user clicks on that link, it shows you, oh, this application wants to access your data, wants to access your email, it wants to send email on your behalf, etc., etc. So this is a thing that threat actors also abused in the past, and they still do. Attack 3 is what I call APT style. So do some recon in your environment and then try to steal important data. So I've simulated all these attacks, and the good news is that the data set that this is all based on is also publicly available, and I'll share the link later, where you can basically do your own analysis based on this data, which is pretty cool, I think. So attack 1, the BEC one, what I did is basically 4 steps, and then below each step I added the MITRE attack phase that it belongs to. So forwarding rule relates to persistency, performing email log searches relates to the collection phase of MITRE. So this is a very controlled experiment in my environment, in my Google Workspace test environment. So what I did was I performed all these steps and then went away for a few hours because it might take some time for all the logs to end up in there. And then I counted all the events that are related to this attack. And then I run alpha against it to see if it could find it and if it could generate a kill chain statistic. So in this case, it did. So there are 47 events generated because of this attack, and the kill chain statistic associated with it was 0.9. So there's a very high probability that if you were to use alpha, that you would have seen this and that you would have investigated it further. So this is good news. But I want to be honest, the next attack, not so much. The malicious app is very difficult to detect, I would say, based on the logging in a Google Workspace environment for a few reasons. So what you do is you register an OAuth application, but you do that outside of Google Workspace. So there will be no record in Google Workspace audit logging about this. When you send a link to an email, or you send an email with a link asking for permissions, there will be no record in the audit log that there was an email basically sent. Yeah, there will be, if you go search through everyone's emails, you will find that email, but there will be no audit record that a link was received, for instance. What you will see is if someone approves, clicks on the link and approves it, then it will be registered in the Google Workspace audit log, because then it will say like, this application was given permissions by user X. And then what will also be registered is if that application starts doing stuff on behalf of you. So that will also be registered. This attack, as I mentioned, it generated a few logs, 14 in total, but most of them being the application requesting permission, or basically the application authorizing on your behalf. Alpha was not able to find, or at least to identify this with the kill chain statistic method. So yeah, this wasn't successful for this specific attack. Attack 3, the APT style. So we log in, and what we're going to do is we use something in Google Workspace where you can, what you can do is pretty useful. You can get an export of all the users and their roles. Just in the environment, you can click export users and roles. It'll give you a CSV with everyone in there. Pretty useful, but it's also logged, so it's really good for us. What you can also then do is perform exfiltration. What I did was performing exfiltration of emails. So in Google, you have something called email log search, where you can simply search for emails based on sender, recipient, etc. It's a bit like e-discovery, but not really the full-fledged e-discovery suite in Google. And I also did a Google takeout. For the people that don't know, Google Takeout is pretty powerful, where you basically say, give me everything Google you have on this account. From a threat actor perspective, it's pretty useful because you can then basically inspect the data, see if you can either extort them, blackmail them, or maybe use that data to perform a second attack on other websites they are registered to. So pretty useful. So I performed these activities, and luckily this was detected by alpha with a score of 0.65, even though there were only 7 events generated in the audit log. So I was pretty happy with that. This leads to the conclusion. So out of the 3 attacks, 2 were detected, I would say, so it's pretty good. Still, I think what's very important is what we do is we say in the tool itself, there's a config file where you say, oh, an attack gets detected if it generates at least 5 or 7 events. You can change that value. So if you set that to really low, you will have way more subchains, but you might also generate way more noise. On the other hand, if you want to say, I only want it to generate a kill chain statistic if it has at least 10 events, you might miss a lot of stuff. So that's what I mean with tuning. You might still need to tune it to your environment. In my environment, as I mentioned, it's my environment, so I have it under control. It's okay with the current settings. But what it really needs, and this is the area of improvement, is larger data sets and environments. So if you have Google Workspace, please give it a try. Or if you have a client that you've done an investigation for and you still have the logs, please load them in and test them. More attacks. There are definitely more attacks against Google Workspace that can be tested. And when I started, I mentioned event mapping. So what we did was basically grab all events from the audit log and try to map it to the MITRE phases. Well, what if MITRE decides to add more techniques? We need to redo the mapping. Or what if Google adds additional logging? We need to add that mapping in. So these are areas of improvement, and I think it's continuous. The most important slide is coming up right now. And this is the too long, didn't listen slide. This is for everyone that was doing other stuff. If you read this, you should be up to speed a little bit on this presentation. So I think Google Workspace is relevant because it's an entry path, just like Microsoft 365. Email is often an entry point for serious attacks. So and Google Workspace is going to grow because Google is behind it. They're going to invest in it, and it will be around for years. It might change the name again and again, but it will still be there. Audit logging is on, super important. Alpha is the tool that we developed, and it's available for free. And I hope you want to try it. And I would really appreciate your feedback because we've developed this in our little echo chamber, but there might be other environments that this scales very well to, or maybe not. So please let me know. So if you want to help, as I mentioned, the tool is on the top link. So that's on our GitHub. And the second link is to the data set. So I did all these attacks, I performed them, and then I made an export. There's some very weird data in it, like because I just needed to come up with stuff and made a little bit of all kinds of weird stuff, but I'll leave you to it. I think I removed all IPs belonging to me or other people that worked on the project. But if you find one IP from someone in the Netherlands, please don't DOS it. That's my address probably. There's also a YouTube link, and this is if you want to set it up, you can just follow this link, and then I will show you exactly how to do it. And actually, I think in 2 minutes, or maybe right now, there will be a post up on Medium on this link that will give you sort of what I talked about today in a more text format, where you can just simply follow all the steps. And I will show you how to use this tool with examples, etc., etc. So please go there and check it out. We're almost there. I have a challenge for you. It's pretty difficult to see for the people online, but who in this room uses LinkedIn? That's pretty good. Well, I had a goal at the beginning of the year to have 1,000 followers in LinkedIn because I post a lot of stuff there. I think I'm at 990 or something, so I hope at least 10 people online or here can just click follow, and then I'll have that goal crossed off for this year. So please go ahead if you use LinkedIn. I won't do any sales pitches there, but I'll just post hopefully cool content there. So this is what the site looks like. I think we're the only one with this specific name, so should be easy to find. And then I'll open up the floor for the next part of the challenge. If you like this shirt or the white version of it, you can win one. If you have a question for me and I like the question, the best question, you get a t-shirt. Doesn't matter, I have small, medium, large, extra large. Everyone can have a t-shirt that has a good question. For the people online, you can still ask the question, but if Phil says it and I really like it, Phil gets a t-shirt, so or Heather. So yeah, this was what I wanted to share with you, and